Hey, what's up? It's your old pal, Mr. Cook, and we're working on the Unit 6 test review. We got through the first and second page, and now we're working on some of these word problems. So that first word problem, number 35, it took a lot to explain and write down all the formulas and all that stuff, but now that we've got that under our belt, let's go ahead and work through the rest of these problems. They should be pretty easy to work through from here on out. So it says to determine the time it will take $2,000 to triple in value if it is invested in an account that earns 12% interest compounded monthly. So when it says compounded monthly and not compounded continuously, it doesn't have that keyword continuously, I know it's a compound interest formula. So I'm going to use the formula A equals P times 1 plus R over N to the N times T. And once again, the formulas will be provided to you on the test. You just need to know what to plug in. So P is the starting amount, so it looks like that's going to be the $2,000. And then R is the interest rate, which is 12%, so 12 divided by 100. That's going to be equal to 0.12, so 0.12 over N. N is how many times it's compounded per year. So if it's monthly, how many times per year is that going to be? There's 12 months in a year, so divide by 12. And then your N value is also going to be 12 up there. And it says determine how much time it will take to do that. So we're going to end up solving for the T value. So what does that mean that we need to know about the A? Well, it's asking us how much time it's going to take for $2,000 to triple. So if I tripled $2,000, how much money would I have? All I'd have to do is take 2,000 multiplied by 3. So 2,000 times 3 is 6,000. And now to just solve it, all I have to do is just get the T value by itself. So I'm going to, simplify it as much as I can. Like I'm going to find out what this number is right here. Just use my calculator. So let's see what that is. 1 plus 0.12 divided by 12. I can, just do that. That's fine. So it's just 1.01. So just rewriting this, 6,000 is equal to 2,000 times 1.01 to the power of 12t. Now this is like one of those problems where I'm solving and it looks like it's one of those exponent ones. So I'm going to circle my exponent. I need to get it all by itself. So I need to get this exponent by itself. So the problem is that I have this times 2,000 in front. So the way that I get rid of it is by dividing both sides by 2,000. And sure enough, when you divide 6,000 by 2,000, you end up tripling the amount. So that's going to turn into just a 3. And that's equal to 1.01 to the power of 12t. Now, once we got it isolated as an exponent equals a number, just like on the previous page, we're going to turn this into a logarithm. So when I convert this into a log, it looks like this. Log with a base of 1.01 of the number 3 is equal to 12t. So now, just to get the t by itself, I would just divide both sides by 12, because I can do this on my calculator, and then divide it by 12, that gets t by itself. So let's do the whole thing at once. So we do the log of the big number 3 divided by log of the base, so log of 1.01, and I get that number, and then I need to divide it by 12, and that tells me the number of years that it's going to take. So it's going to take about 9.2 years for the $2,000 to triple. So that's, pretty easy. That's how we solve number 36. It's just recognizing which formula you're going to use and then solving for the variable that you need. Number 37 says the number of deer in a certain state is given by this function. So that's pretty cool. We don't have to make an equation or anything like that. They give it to us already, where t is then measured in years. How many deer will the state have in 5 years? Well, this is super easy. All it's asking you to do is just plug in 5. So let's plug in 5. 7,600 times e to the power of negative 0.03 times 5. All right, so just type it in, and let's see how many deer that we have. So that's 7,600 times e to the power of, and then it's going to be negative 0.03 times 5 equals. So we have 6,541 and a little bit more than that. So it says around the answer to the nearest deer, so it looks like that would be the answer, 6,541 deer, because it doesn't round up. All right, so that's it for the number 37. Now for number 38, the size P of a small rodent population at time t in years follows this function. So again, they just give us an equation for it, so that's really nice. We don't have to make one up. if they have enough food and the predator population stays constant. So that's just a little bit more that they're adding on to the function there for little qualifiers and parameters. How many years will after how many years will the population reach 4,000? So they're asking us to solve for the amount of time, t, in years, for the population to get to 1,000. So 4,000 is going to be the amount that we plug in for the p. So let's go ahead and do that. So 4,000 is equal to 1,000 times e to the power of 0.17 times t, and we need to solve for t. So this is another example where we have, just like number 36, an exponent, and we need to get the power. So I'm going to circle my exponent, e to the power of 0.17 t. I need to get it all by itself, so I'm going to divide both sides by 1,000, because that's how I get the exponent by itself here. So I get 4 is equal to e to the power of 0.17 t. Now, e is just another number, so you can turn this into a log and solve. So this is going to be log base e of 4 is equal to 0.17 t. Now, this is where it's important to know that log base e is actually something that's found on your calculator. It's the ln button right there. ln is called natural log, and it's when you have a log with a base of e. So I can just rewrite this. Instead of log base e, I can just write it as ln of 4 equals 0.17 t. So that's something I can type into my calculator, ln of 4. So ln of 4, I get some number, and then I need to get t by itself. So if it's multiplying by this 0.17, I just divide by 0.17 to get my answer. So that means that t, the amount of years it's going to take for the rat population to get to 4,000 is, let's see, it doesn't say to round to anything, so let's round to 2 decimal places, 8.15. So 8.15 years. So that's 8 years of the rats conspiring to, grow their population. So that's it for these word problems. I think that's a good place to stop for this video, and then we'll tackle the graphs. And the graphs can take a little bit of time to work through, unless, of course, you have a graphing calculator. So if you have a graphing calculator, get that one ready. And if you don't, maybe you might want to borrow one from your best pal or somebody that you trust, to borrow the calculator from. Or I guess that they'd have to trust you. But anyways, we'll work on the graphing on the last video. So that's it for this one.